Good evening to you, students. How are you doing today?
Fine, thank you, sir. How are you?
Doing thanks. Could have been worse. The rest of it good?
So far, so far.
Yes, sir.
Yes, sir.
Yes, sir. We're okay.
So far.
Yes. Nice. All right. So some of you may be wondering why it is the time to starting. I normally give a little grace period between classes because I know some of you are coming in from work, catch the last part of your 5 to 7 and just need maybe a bathroom break or just to grab something to eat. So I normally give up a little grace period. So I have been here. So as we develop this relationship, this bond, you will understand the routine as we go along. So don't think that I am late for class. I am not late. I've been here. I'm just giving you a little bit of time to just sort yourselves out.
Okay, sir.
No
So I have to
problem.
turn back to come to class, to come back to work to join the class
Are you
because of
serious?
traffic. Yes, I had to turn. I leave work from 4:15 and I have to turn back to come to work to go back to join the class because of the traffic.
It rained. Yeah. There
Yes.
is a relationship between rain and traffic.
Mm-hmm.
Yeah, man, sorry about that. All right, so guess what now? Oh, are you live far from work?
No, sir, I was just going to Stony Hill.
Oh, Jesus. Trust me, I know how far that traffic can go. That traffic can join from Hillman Avenue there to go all the way up to Manor Park. So me know what it's like. All right, let us see how far we can go. Now I'm gonna bear that in mind that you are still at work. But let us see how far we can go today.
Okay, no problem, sir.
Yeah, man. All right. So students, I trust that you were able to reflect on our conversations. I'm seeing 1 or 2 people joining the group via links. So I'm thinking that they are new students to the class. I'm really hoping that you are of the mind frame to work. I'll just say to you that we need to start from day 1. Once we start from day 1, trust me, nobody can fool us. So this is it. This is day 1. I'm going to ask that when I ask you questions that you don't sit and pretend as if you don't hear. It shuts me down when I'm teaching because that's what gives me the energy, especially for a 7 o'clock to 10 o'clock class. I won't keep you until 10 tonight. But especially for a long class, I need to get that energy going. And the energy that I get is not from a Red Bull. It's from my students speaking back to me so that I know that they're learning. All right. So we are on to, we have 7 units to complete. And we're on to unit number 1, numero uno. And we're going to be looking at limits. We're going to be looking at limits. What is a limit? When somebody say, the parents among us, when they say to your child, you stretch my limit, you know, you go on. Wait me, talk to me.
The
Just a
minimum threshold as much as you can manage.
Okay, all right, go ahead, next.
All right, so based on what you're saying, when you refer to the parents, it's the range of what's the term now? Tension. I guess that's what I'm looking for. That the parents will tolerate before they give appropriate action.
Okay. Caswell, when you talk about appropriate action, what are you talking about?
Well, they mention when you
No. I hear you, Caswell. I just ask you, when you say appropriate action, what are you referring to?
I'm referring to the limit statement that you're asking about
I
there.
know. Him not get no
Don't
man.
lick.
Some lick. Come on, you're going like you want pulpitize or something. Just tell him some good lick, man. Yeah, you're right. You're correct, man.
I don't believe in but then again, we know something still.
Okay, you don't believe in beating, right?
Yeah, there's other ways to penalize and that work just as well.
All right. This is not on the syllabus, but I'm going to tell you, with one student being killed so far in the start of the school year, not even 2 weeks in a school, good. And one takes knife stab one, next one kill them. Them want some good lick under them skin. You understand? Because if you have one dispute the day before, and you could have go to your yard and sleep and connive, say you go carry one weapon, go to school today, you go defend. And then the result of that is going to be in death. And if you get some good lick on their skin yesterday, and then trust me to the coolest hours today. I'm sorry, do I sound violent?
No, I actually wasn't aware of that.
No, sir. No, sir. Some good lick.
Trust me, man. Oh my God. Imagine you being a parent and you send your child to school and then
Get that
the
news.
next thing, you get the news, say you pick now come home. No, Crosswell. I'm Crosswell, sorry. Let me tell you something. Oh, Jesus. Anyhow.
People that always say
Incident at Excelsior, sir?
No, sir. It's crazy. One school down the road, down the town.
Oh, don't tell me nothing.
Kingston Technical.
Oh,
Yeah.
Kingston Technical,
No wonder.
because I didn't get any news. I didn't hear any news.
Yeah, man. But you know, it's
technical, they make sense.
yeah. So I'm not a proponent of
What that's supposed to mean, Croswell?
Abuse, child abuse. Oh, but then get some lick.
Yeah, I'm not a proponent of it because I mean, you know, as Croswell says, you know, some people really take it out, you know, to the full blunt and it becomes abuse. And you know, yes, I don't agree with it either, but if you train your child, as scripture says, the way your child should go, when that child is old, that child will never depart from it. But never tell you, some of them tough back boy and girl, yeah, in them school, you want some good fun in them skin to straighten them out. Me so leave the classroom, you know, because I am not going to be putting up with all of them foolishness here. Well, granted, I'm in tertiary, but me couldn't win one high school back for go teach. No, sir. Me would have start self-clean and start. Can't keep up. But that's what it means, though. Yes, limit. It means that it reached its maximum and can't go no further. So guess what? When the teacher say, and then, oh boy, thank you, Jesus. And then when you see the video surfacing of the teacher right on board and picking a rub off a teacher, it makes you wonder what is happening in our schools. But
Oh, yeah, when I used to go to Excelsior Primary, my stepmother always mentioned when she used to work over at the canteen, she'd always mention in past, like say, you know, so like say this exercise teacher just did from stress this morning. She always mentioned that to me. And this was like when high school sent them, they always a fight regularly.
Yeah, man. And Crosswell, let me tell you something. Is it that teacher, yeah? Me not put no stress on my head. No, sir. Me'd rather say, good night. I'm gonna lay down and sleep. But it's rough. And I mean, I'm not only speaking about teachers. I'm speaking about everything else. Listen to how you can reach your limit. Imagine you have your mortgage to pay, your rent to pay, bus fare or gas money. So, well, I'm not going to put food there because food are the last thing we take care of. I hear you. And the likes. And you know, say the limit of your salary is X amount and you can't reach no further. Yeah, you reach a limit. You maximize it out. So that's what we're going to be looking at today. We're going to be looking at some limits and we're going to be seeing what is happening. Now, one of the things that, as I said to you, how it is that I do my online teaching, it is, and what I want from you is, normally I want to get feedback from my students because the feedback helps me to to become a better online teacher. Yes, you're going to be required to write your notes. Yes, you're going to be required to make your own little jottings, but I will also be kind enough to share what I have with you. I'll be kind enough to share what I have with you. So I want you to pay attention. I don't want you to just sit back and say, okay, so I'm going to send this, I'm not doing it. No, man. Take your notes, make a notation, all right? And the recording will be available so you actually see what it is that I'm doing here. All right, so let's go. So we're going to be looking at the intuitive approach. The intuitive approach to our limits, the intuitive approach. Now, let me help you to read what is happening here. Right? So I'm making an adjustment. So you may see the screen go blank to one side. I'm just making a small adjustment to something. So what this is saying is the limit as x tends to 1 of the function x plus 1. It's the limit. Let me spotlight so that you can see what is happening. The limit as x tends to 1 of the function x plus 1. So you want to find the limit of this function as x approaches 1. Now, let me just tell a secret. X is not equals to 1. In this case, it is not equals to 1. X is approaching 1. Now, unlike you, young people, who always say, let me see how close I can go with my little girlfriend or my little boyfriend and then pull back. And then you recognize, say, you can't pull back because it's like magnet. Let me see how close I'm going to go to the edge of the swimming pool without dropping into the pool. Let me see how close I can get to this, or let me see how close I can get to that. Let me see how close I can do this. Let me see how close I can get to a C minus so that we can just barely pass a course, right? It is not the actual value that you're putting in. It is approaching the value. So your aim is to get very, very, very close to it, but you're not reaching it. You're not reaching it. So I am going to be investigating. When I look at the number line, I can approach 1 from 2 ways. I can approach 1 from the left, and I can approach 1 from the right.
So, let me see now.
So because I can approach 1 from both ways, I need to investigate both ways. Now, some teachers teach that just plug it in and you're good to go. We'll have some conversations about that. So we don't need to do an investigation. What happens to the left? What happens to the right? What happens to the left? What happens to the right? I hope that you guys are paying attention and nobody is TikToking as I go along. I want you to be able to pay attention.
Yes, sir, before you continue.
Because I'm not okay.
Somebody saying something?
Yeah, so I didn't.
Yes, sir. In terms of the lowest, what's that? Lowest. What does LHS stand for again?
I'm going there. I just want to draw something and just show you what is happening here. I'm going there. Give me half a second and I'll get there. What is this called?
Number line.
A number line. All right. This is what I'm interested in. 1. Why, sir? See right here, sir, extending to 1. So I can approach 1 from this side. And I can approach 1 from that side.
Mm.
Now, when I approach one from this side, it's going to be my left-hand side. When I approach one from this side, it's going to be my right-hand side. So I'm approaching one from both ways, left hand and my right hand. And stick up it because math is practical. I don't want anybody to tell me, like one LD person said last class that, it's a long time and I don't like maths. I don't care. Math is practical. You know what? Somebody said in class today at the start of the class, sir, I was on my way home and I had to turn back. And mathematics, she calculates, this is this time, with this traffic, there is no way I'm going to get home. I'm going to miss class. It is easier for me to turn back and get to work. Mathematics. Big mathematics, big calculus a while ago. So we're going to approach the left-hand side. We're approaching the left-hand side. Approaching the left-hand side, I'm going to have 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and after 0.9, and I'm going to have 1. So I'm saying to you that 0.9, in this your case, is close to 1. So I don't have 0.9. I'm approaching 1 at 0.9. No, I want you to watch this because this is important. Between that is my 0.9. How much closer can I get between 0.9 and 1? And I'm saying to you it's going to be 0.99. Oh. So to get even closer, sir, I'm going to go 0.999. Two. And even closer is going to be 0.9999. So all I'm doing there is to use these values to substitute into my function. So I'm going to get 0.9 plus 1 is equal to 1.9. 0.99 plus 1 is equal to 1.99. 0.999 plus 1 is equal to 1.999. Can you see that?
Yes, sir.
Sir, I have a question.
Yes, sir.
Yes, sir.
Go ahead. Nice job. Go ahead with the question, please.
Okay, sir. So why didn't it said at the left side of the equation lime, which is LAM, and in the bracket you have 9.0.9, and then you have plus 1, and then it equals to 1.9.
LAM, what is L? Oh, lim. Oh, it's a limit.
Yeah.
It's a limit. All right, ask a question again. I got distracted when it said LAM or LI. It's LIM incidentally, but yeah. Go ask a question one more time, please.
Okay, sir. So the result of the function when x is 0.9 is equal to 1.9. So why didn't it, for demonstration purposes, had lime in brackets 0.9 plus 1? So it can be more clear, because I was like, what would this equal to?
No, no, these are just my notes, that's what I'm explaining. No, man. Oh, no, this is calculus. Sorry. So this is big school mathematics. Is it done? So right here, you know what teacher could have written? Teacher could have written 0.9 plus 1 is equal to 1.9. What teacher is doing, because teacher want you to make your notes, so teacher want to put in enough information on screen so that you can go on fill in the blanks. It's one way to get you to be a part of what is happening. All right, I'm done.
Yeah, understand. Sir.
Yeah, man, good. So now, when we would have done the substitution of our, remember, no, this is the intuitive approach. The intuitive approach. When we would have done all of that now, we are getting 0.1. We're getting 1.9. 1.9 approximates to what? Whole number.
2.
2. Very good. 1.99 approximates to what whole number?
Still 2.
Yeah, man, under 1 year?
Still 2.
All right, good, good. So what is going to happen now is I am going to investigate now from the right-hand side. I'm investigating from the right-hand side. So when I investigate from the right-hand side, that's going to be 1.1. 1.1. So you're going to use 1.5. Look how far 1.5 is to 1.
Based on the pattern that I'm seeing, you're doing this in increments of 10.
Increments of 10?
Yeah, because from what I'm seeing, on the right hand side, it increased from let's say I think this is 1,000, 10,000 all the way to the 10th in on the.
Hold on. I'm increasing by what, Crosswell?
Yeah, I'm saying you're increasing it by 10. Because
Okay. No, hold on. No. I know what you're talking about, you know.
Mm.
Do you all agree with him that I'm increasing by 10?
No, sir.
No.
What am I doing? Increasing by what? What am I doing? Where am I going?
You're increasing by 1, sir.
Oh,
0.1.
I'm increasing by 0.1. What else? Anybody else?
So you're increasing by 1/10.
I'm increasing by 1/10.
Yes,
All
sir.
right. Okay. Crosswell, look at this.
So you're increasing by 2.
Excuse me.
By 2.
Show me where the 2 is. No, I don't think you're following me. What is happening? What is happening? Remember this from little school? I don't like how this thing is so thick. Hold on. Remember from little school?
Hundred, tens,
Yeah, man. And then what come here, so?
tens, hundreds, thousands. That's a pattern. And then
Okay, Crosswell. No, Crosswell, hold on. Because if you're telling me this, why you tell me so we're increasing by 10 then?
no, when I said that, I was making. I didn't actually complete my statement.
No, you did complete it. Come and ask you for repeat, and you repeat the same thing. So you did complete it. So correct yourself now. I'm increasing by what?
Oh, Christ. You increase, well, I would say you're increasing increments of, what's the term now? 1/10? No, not 1/10. Yeah, I believe 1/10 is a
Okay, 110. And this is going to be right now the TH. So 10th, hundredths with the TH, thousandths with the TH, don't it?
Yes.
Because this is a decimal point. Talk truth. Hello, somebody?
Yes, sir.
No, I'm asking the question. Do you remember this now? 100 tens and ones?
Yes,
Then you have
sir.
your tenths, hundredths, thousandths, 10,000ths, and those TH come after
Right.
the decimal point.
Mhm.
So I'm not increasing by tens. I'm going into the tenths position.
10th, 1/10.
Right. Okay. So having cleared that up, let us continue. And this is why it is important for you to speak to me in class, because if it means that I have to go down
Memory
to a
lane.
lower level just to get you to concretize your understanding is very important. I want you to speak to me. All right. So let's go. So I was saying earlier, You may say, sir, why we never go 1.5? Look how far 1.5 is to 1.1. Yeah, man, we want this something close. It's just you and the Holy Spirit. It's just you and the Holy Spirit alone can pass through. Just the Holy Spirit alone want to pass through. We want it close, 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 close. All right. So we're going to go to 1.1. But when we put 1.1, we recognize say, we can't go closer, you know. But guess what? When we go close, we're going to go 1.01.
1.01.
Yeah, man. And then 1.001 and then 0001. And when we fling this in at something now, remember, it's an investigation we're doing, you know. It's an investigation we're doing, and that's why it's called the intuitive approach. You know, so my intuition tell me, say, you have one boyfriend, you know, or my intuition say, you have money. My intuition say, you know, go to school, and I say, no, go to school. It means that it's a thought, it's an idea. And then now you're going to develop that idea or that thought into something now where it is that you can check your hypothesis, your theory. And then again, see if it makes sense. One of the theories that you can check is that, all right, no problem, man. You have somebody who live up at the top of the road. You go stand and say, oi, Sister Mavis, look and see if you see Bertie go up at the road. Yeah, man, him just gone in at the bus. Okay, fine. Him take the bus. And at the bus him take, that bus there can go to school. So your hypothesis there's a breakdown because you know, say him is in the direction of going to school. But if when you do your investigation or Miss Mavis say, I mean, I sit on the veranda, you know, I mean, out a gate, I don't see him pass. You know, so boy, now go nowhere. That is your intuition. So you're doing your investigation. So when I got my 1.1 and I substitute my 1.1 into my function, x plus 1, then watch this, you know.
Sir, I have a
1 plus,
question.
go ahead.
Sorry to interrupt. So is it that it always has to be a whole number?
But these are not whole numbers.
So as in like everything I eventually add up to just 2. That's what I mean. But if it's going to
Well,
like be
we don't know.
whole number.
We don't know. We don't know. Make us see now. Make us see. All right. So when we substitute this 1.1 now into the original function, which is our x plus 1, we're going to have 1 plus 1 plus 1 is 2.1. Make us see what's going on. 1.01 plus 1 is 2.01. But hold on, sir. There's one pattern, you know, because over here say start with 1.9. Then I go to 1.99. And then I want to 1.999. So I mean, I work with that one, I'm just going to put 49. But sir, I'm also seeing a pattern here, sir, too. Because at 2.1, then I go 2.01, then 2.0. Oh, sir, you just put the, me see it, sir. But hold on. When you round off 2.1, where you get?
2.
This is approach to what number? 2.
2.1 is
And I want to approach what again?
2.
2.
2. So the one of them approach 2.
As long as the value in the tens range doesn't reach 5, it will always mean as.
Okay, all right, good. You're remembering that, all right. So we're going to say that this limit is of a good behavior since the limit approaches numero dos from the right-hand side and from the left-hand side. So it is of a good behavior. And let me show you how the mathematics is real. Let me show you how the mathematics is real. You know, say, you have some friends who will tell us, say, they get 80% on the test paper.
Yes.
I say, oh no, man, my friend not telling me a lie. My friend have no reason to tell me a lie. And then 2 weeks down the line, you and your friend talk and say, boy, you know, me did fail. The first time I forgot to do it over, and my friend say, you know, I forgot to do it over twice, but hold on. So my friend, if I remember, say, my friend did tell me, say, them they get 80%. Blow out the friend lie. And you know, say, no, you know, so you try find out now if other situations may come to the fore where you can not trust a friend. What's the point I'm making there? It is that your friend says something one way, and then the next time the friend can say something another way, that friend is not of a good behavior, because two things come out of the friend's mouth, and the two of them don't sound alike. But if you have a friend, or when a friend asleep, and you ask a friend to tell you how the story did go, and at the same way, you know that a friend for life, the limit is of a good behavior, because it approaches the same number from the left-hand side, the same number it approaches from the right. Then, sir, what if it's two different numbers? Then we say that the limit is not of a good behavior, and the limit, therefore, does not exist. We'll say that the limit is not of a good behavior, and therefore the limit does not exist. The limit exists when, from the left-hand side, the investigation from the left-hand side equals the investigation from the right-hand side. If the two sitting them no match up, one are something and the other one are something else, the limit does not exist. And I want you to pay special attention, because I'm going to be moving into something that is called piecewise function. And this concept is going to be very critical for piecewise, very critical. So you must understand this notion before you can fully understand our piecewise function. What I said a while ago, a whole heap of something, you know. So may I press pause? I'm going to ask a question if we don't understand, but before you answer me, you know, let me tell you how I stay. And COVID has brought on so many good things. And one of the good things about COVID for me with online teaching is that when me say something in a class and them say, no, sir, you never say it, we just go play back the recording. So I'm going to say this now. When me in the face-to-face class, what if I like them tell me, I didn't say that. Yes, sir, you say it. I say, all right. No, and me get the recording, somebody can't purge it. Hear me out. If when I ask a question, are you understanding? And if you know they not understand, and you shut up your mouth, and then you come to me afterwards outside of class, sir, I wasn't fully understanding. Can you explain? No, me not explain to you. No, me not do it. I want who we can call. I want when Arthur Lee asks me the question in the class, and I answer 3 different ways and she still not get it. Me say to Arthur Lee, Arthur, link me after class. Me will find another way, because me try in at the class. What's the point? I want you to use the space to maximize your teaching. I don't have private classes. And all of us are going to learn right in this space. So when I ask a question, I'm expecting you guys to answer me. Let me tell you, say, talk to me afterwards. And if you don't want to say that in the class, I'm going to send you one private message. Or speaking about private messages, I have a deficiency. When I teach and I get excited in the teaching, sometimes I forget to check the chat. So every now and again, if you put something in the chat and I don't respond to it, just nicely say, remember the chat, sir. Go ahead, Williams.
Yes. In regards to the teaching style, sir, it's a lot easier to grasp than some of the previous teachers in.
Yeah. No call on him. No call on him. No call on him. Yeah. No call on him. No call on him.
I'm not calling any name, sir. It's just that some of the teachers we had, the last teachers that we had, they were very demanding, and as a result, a lot of the students were that's the term now.
Free to ask. All right. So guess what now? I'm creating a nice environment so that you can feel very comfortable to talk to teacher. Johan. Jojo.
Sir, hold on. Sir, I understand, you know, but is it that the formula L and X plus 1 is going to always be X plus 1?
No, ma'am. Do you always eat chicken and rice every day?
Yes.
Say no. Say no. All if I eat chicken and rice to eat every day, say no. No. And that's one of the things that I get very often in class. Mathematics is not static. And earlier, I don't know if anybody heard when I said that X is not 1. Anybody remember me saying that X is not 1 at the start of the class?
Yes.
Yes, sir.
Yeah, man. Because every time somebody said the variable X, the variable X, them say, oh, sir, X equal 1. I'm gonna knock you silly. X is not equal to 1, it's a variable. Variable. It comes from the parent name for variable is, say vary.
Very.
Yeah, man. And when something varies, what happens?
The state of the its state is it can change rapidly.
Always
This
changes.
is the point I'm making, it can't change. So X not have one static number. It's a variable, so it can change. Negative, positive, 0, fraction, proper, improper, you name it. Yeah, man. So don't get into the habit of saying X equal 1. X is 1, sir. Don't do it. Don't do it.
So but sir, since you bring that up, is the case whenever we get a question like this, X would be being in reference to whatever value that we get. So like say X is approaching 5, X is approaching 3, X is approaching 100, something like that.
Yes, I.
Okay.
Yes, I. Matter of fact, I can approach all infinity. Yes, I. All right, very nice. So I ask the question again. I'm going to ask the question again. Are you all following? Is there someone in the class that wants me to? Lucky, I see your hand. Go ahead.
Sir, I just wanted to know if you have this, if the variable 0.9, if you could just give us that and said, find what is the limit of X to 1, X plus 1. If you don't, you wouldn't give us 1.9 or anything over that side. You just give us 0.9 and we must work the X plus 1.
Yes, ma'am. Let me ask you one question, Lucky. Sometimes in the opening cupboard, I see one little flash out and 2 slices of bread. Where you go do?
The bread and the flash out.
Okay. And then our next time, when you open the cupboard and I see a lobster, where you go do? It's not, you see the point I'm making? So whatever they give you, you are going to work with. So that question is very similar to what Joanna asked a while ago. So whatever they give you as a limit is what you're going to be using. It's not always going to be 1. It's going to be a different number. And I think I responded to Crosswell in that same regard. So I know you're getting excited. Don't feel no way. See me feel a way you're asking them questions. No, man.
No.
When I think, and I that I want. So yeah, all right. Now, I ask a trick question, if you guys are following. I'm gonna say yes. Because one day, I'm doing a class for me now. No, me no want nobody tell me, say, sir, me never understand too good enough, because when me give it a chance to tell me, say, when you never understand, when you never did do it. So no, cockroach. All right, cancel. My computer is very, very, very delicate, so I have to be very careful with what it is that I am touching. Very delicate. All right. No. So it was a trick question. Are you following? Yes, sir. This example.
Yes, sir.
But sir,
No, sir, from my end.
is this one like with teacher? No. Teacher give you the easy example, and then after that, no, them give you one for do when no look like what them give you. Okay, that's fine. They did the same thing to me too. I am going to press mute for about 3 minutes. And I want you to use that time to attempt the question, and then I'll chime in and I'll see how far you can get to the question. All right. So I'm muting and you are going to start. You're doing the same thing like what? I want you to evaluate the limit of this function. You're evaluating the limit of this function. All right. On your mark, get it, go.
Sir, how many times? Like 4 times? 5?
Yeah, 4 times. And I'll respond to that. But 4 times, yeah.
Yeah.
Sir, I'm finished. Just saying. And remember to check the chat as well.
Sorry, say that again.
Sir, I said that I was finished, but
Okay, good.
I sent you something in the chat, but I'm not sure if I'm entirely correct and if I
That's fine.
did it right.
Okay,
Yeah.
that's fine. I'm not interested in right answers just yet. I'm just interested in the process. Okay, I see your answer. Thank you. The rest of you, how we stay? We're finished?
Yes, I'm finished.
Drop your response in the chat. Let me see. You can direct message me in the chat so that you don't. Let me just see what it looks like.
The whole process? It's kind of long for me.
No, not the whole process. Just a final answer.
Okay.
I will go through the process with you. Nobody now said nothing. Well, you still working? Am I trusting that you're still working?
Just that one, sir.
I need more to come. More. Seeing those responses, I need others. There are 20 out of you in the class. Come on. I don't think you guys are understanding because I'm counting how many direct messages that I've got. And at this time, you should be putting your answer in. I don't want you to type out the whole process. No. All I'm asking for is your final answer. And if I can't get it, it means that you guys are not understanding. All right. So I got 6 responses out of 20 2 students. All right, hold on. My bad. All right, so I'm using 2 devices, and I just looked up and saw some on the other device. I was actually counting the device that I had. Other device that I'm using. Okay. 7, 8. All right. So let me move on. As it approaches 2, as the limit approaches 2, it approaches 2 from the left-hand side. What am I going to be using? It is approaching 2 from the left-hand side. What will be my number?
So 1.9.
1.9.
Mm-hmm. So me like teaching and students learn. No? Yeah. 1.9.
Hold on. You get the 1.9.
Mm-hmm. I like your response. You tell me, look at it again and tell me how you think them get the 1.9.
Wait, you talking the answer, sir?
Mm-mm.
Oh yeah. I got this. I got the same conclusion.
Okay. Talk to me now, not the conclusion, your guess.
My thought process.
Yeah, man. Yeah. 1.9. It's between 1.9 and 1.99. From the right hand side, what does it approach to? What's the first one?
The first one is x approaching 1.
Mm-mm. Mm-mm.
X is approaching 2.
Yeah, x is
X is
approaching.
approaching 2 where you have X and the
Yes.
arrow pointing to 2.
Yeah.
On the limit.
Yes. So from the right hand side, it's going to be what?
2.1.
2.1. Then the next number is going to be what?
Wait, I didn't hear anything.
2.01.
2.01.
2.01, then 2.001 and on.
Excellent. So those of you who sent me 4, I want you to look back at it. Look back at it. Because when I substitute 1.9, I'm getting 3.22222. 1.99. This is what is happening? Here, my guess was so far off. 3.2222. But when I got closer to the value 2, the limit is rounding up nicely to 2.02. When I get yet closer to 2 from the left-hand side, it is getting closer and closer to 3. So every time you look at this, you can see that the value is getting closer and closer to 3. Oh, but hold on, sir. That wasn't the understanding I got. I thought that every time you get an answer for the limit and it's not a whole number, you can round it off. No, sir, me never tell you that. What we are seeing is, and that's why I said to you that I was going to come back to, I don't remember who asked the question if you're supposed to. Who asked the question if it's 4 of them is supposed to do? That was you?
I didn't ask.
Who asked that question?
Daniel Thomas.
Oh, Daniel. So Daniel said, sir, it's 4 of them? I said, all right, yeah, okay, yeah. You can go with 4 for now. I'll soon come back to you with that. Right? We don't have to stop at 4. I only stop at 4 because I'm seeing the pattern. You can go along, but I'm going to tell you something. So you go along with this one here, you will end up with 1.999, 1.99999, 1.99999. So you know that this is going to be approaching 2. Here, you can get 2.00001. Then we add one more 0, then we add one more 0. So at some point in time, this one is going to be negligible. So you can say that it rounds off to 2. Or it approaches 2. In this rare case, this 2 is, you notice where the 2 is? The 2 is 2 places closer to the 3. Then it gone 3 places to the 3. Then the next one going to be 4 places from the 3. Then 5 places from the 3. And then after a while, you're going to Jamaica, me in Florida. Me in Jamaica, in Florida. Right? So that's what is happening. So it's not that we're rounding off. What we're saying is that it is approaching this value. This is a consistent value that is approaching. But if you look at the first one, you see, it's why we can't do the first one alone and stop. Because if you do the first one alone and stop against a 3.2. But when we did that second one, we got 3.02. And the third, 3.002. 2. But when we investigated it a little further, we recognized that no, man, sorry, we are gone. Looking at this one here, it's the same thing, 2.8181. That far off, that way, way, way far off. Way, way off. But when we continue, we recognize that the second one is a little closer. The third is even closer. By you reach the fourth one in a ugly start up, you know. Yeah, man. Ugly start up. They know that this no approaches 3. So I'm saying that we can say that it's of a good behavior since the limit approaches 3 from the right and left. Question.
You can go over that for me, please.
Yeah.
What you want me to go over?
So I'm wondering how you get the 3.2222.
Oh, one of the things I never told you is that I work magic.
Yeah, no,
Okay.
you don't.
All right. So you all need to invest in a good calculator, not the one that sell down a Mr. Chin called Kenko.
Oh, I
Kenko
didn't
won't help you.
my calculator.
Kenko won't help you.
Okay.
All right? You need a good calculator. All right, let's go.
So before I continue, sir, I just want to clarify something. From the left-hand side, yeah, from the left-hand side, for example, too, is that you're is that you're adding 2 each time?
I don't know what is being added, Crosswell. What I'm doing now is exactly what I'm going to be writing on screen just now. What I'm saying is limit as x tends to 2 of the function x plus 1 over x minus 1. My initial guess is going to be that 1.9. So in the function, I'm substituting 1.9. So x is equal to 1.9. We are letting x to be equal to 1.9. So anywhere in the function I see x, I'm going to put 1.9. So this becomes 1.9 plus 1 over 1.9 minus 1.
Okay.
1.9 plus 1 is going to be equal to 2.9. 1.9 minus 1 is going to be equal to 0.9. So 2.9 divided by 0.9 is equal to 3.2222. And I can put something there to say that it recurs.
Oh, okay.
Okay.
Talk truth.
Understand now, sir.
Before you move on, I can go back over that, please.
What? Okay, you tell me what you want.
People understanding.
No, make him continue.
All right. Well, I'm not understanding. So for the part right here, you have the lim and the multiplication sign plus 1.
Hold on there, man. That's any multiplication sign, Papa? Leon?
Sorry, the x.
No. Hold on. You can take out $500 of your lunch money and put it in our envelope because I'm going to come calculate for every mistake you make in class like that. I'm going to charge you. I bet you don't make no more mistake.
Okay. All right, so I understand.
All right. That's not a multiplication sign. It or a x.
X.
Okay.
X, yes. It or an x.
X.
Yeah. All right, let's go again. Yes, Leon, go ahead, Papa.
All right, so I was saying, I don't know how you got the answer down at the bottom right. You say substitute all the x's.
Very good. I substitute the value, yeah. Do you have a calculator with you, Leon?
No, I don't have a calculator with me.
That's not the problem.
To the right now, so 2.
That's the problem, Papa. All right, so what I'm doing in the function, this is my given function. So you recognize that this function here for the second question is different from the first because the functions are not static.
Okay, sir.
Sometimes you go to the supermarket and buy a chicken, the chicken fat. Sometimes you buy the chicken mager. Sometimes you can't afford the chicken and you buy the back, but it's still a derivative of the chicken. So I'm saying to you, it's not going to always be x plus 1 over x minus 1. Neither will it be just x plus 1. It could be anything. And you see as we go along, right? So what I'm saying to you is, having this cipher in our minds, where the limit is going to 2, extending to 2. So what is going to happen is that I'm looking for values very close to 2 from the left-hand side. And I'm going to get 1.9. Is 2? Yeah. And then I'm going to get 1.99. And then I'm going to get 1.999 because I'm getting as close as I can get to 2 as possible. Can I pass 2? No, I can't. It will never ever pass 2. A little later on, when I will be moving into graphs with you, I will put something on screen, a graphing software on screen, and then I'll come back to this very point. Matter of fact, I don't have to do that. When I reach the piecewise function, I'll show you exactly what it is. All right, watch me now, Leon, and others. You see the 1.9 right here, so? This is going to be the value that I'm going to use to represent x. I'm substituting this into this function, and I'm going to see what comes out of it. I know what comes out of it is 3.222, but let me show you the working out. Anywhere in the function I see x, I am putting 1.9. So this is 1.9 plus 1, see here? 1.9 plus 1 is going to give you 2.9. And this is 1.9 minus 1 is going to be equal to 0.9. When you have 2.9 divided by 0.9, you're going to end up with 3.2222222. That little dot over the 2 is saying to you that it is continuing. The 2's are continuing. All right. Similarly, that's exactly what I'm going to be doing with the other one. 1.99 plus 1 is 2.99. 1.99 minus 1 is 0.99. 2.99 divided by 0.99 going to give it 3.0202. So all I'm doing is substituting. But remember, you have to have a calculator in a calculus class so that you can follow what is happening. Go ahead, please. Talk to me now. Somebody unmuted just now. I heard a voice a while ago. What is it? All right.
So I was saying that sir?
Well,
Oh, sir, I was saying that I don't know how you did get the 3.0202. I was trying to work that out, but once I saw that you worked for the second one, I understand.
good job. Very nice. Very nice. Let me say something to you. I've been a teacher way too long, longer than some of you have been on earth. And let me tell you what I'm sensing in the class. I'm sensing some of you are, I know some of you are understanding without a shadow of a doubt, but there are a few of you don't have a clue what you're talking about. And you look on the clock to find out what time class are done. And you find every other thing to occupy your time rather than focusing. Let me tell you what I normally do. I will normally give a test at the end of each class, just a little one quiz to see what is happening. Ever so often, I am going to, it's a large group, it's 20 out of you in the class. What I'm going to do is, ever so often, I'm going to drop you in a breakout room.
Hear that.
And we're going to have a one-on-one. I'm going to give you a question to work in the breakout room with me so that I can see what is happening. I may not be for everybody. I may decide that I'm going to ask Sharifa. That name looks very new. I did not recognize that. I don't recognize that name from the last class, but never mind. I can say, Sharifa, join me in the breakout room. And I'm going to give Sharifa something to work. And it will tell me, those of you who are understanding, I'm going to tell you why I'm going to do it. I don't teach students to fail. I don't teach students to fail. And I'm going to force you to be paying attention because you don't know. By the end of a particular period, I'm supposed to be able to go through the class one by one. I may not do the whole class one day, but you don't know who I'm going to be calling upon. It could be Daniel, it could be Dane, it could be Joanna, it could be Latoyo, it could be Kamal, it could be anybody. I'm going to call and just put you in the, me and you one-on-one. So I'm saying this to say to you, pay attention. Calculus 1 is not one of those courses you'll be playing around with. It's heavy calculus that you're doing, no little school business. Big man thing you're talking about. All right? So it's just a word for the wise. Pay attention. Try get it. All right, let's go. Look how none of you can get this one here now. I'm sorry. None of you will get that one.
Sir?
Yes, please.
Good evening. Just a note, I missed the first part of the class because I was at work. So I don't understand what I'm seeing so far. So just just highlighting that part.
All right, no problem. You know what you're going to do for me, hon? You're going to go through the recording when it's posted. And I'm going to start with you come next week.
Sure.
I'll come to you. Harry, go first and then go after.
Yes, sir. In order to have a complete answer, do we have to write the statement where it says we see that?
Audio? Yes, sir.
Okay.
You need to make a statement. Very good question. It's when I reach the piecewise function, they are going to ask you a question. And what I'm doing right here is to help you when we get to piecewise. So when you move to piecewise function, they will say to you, is the function continuous at x equals 2 and x equals 3? You're asking a question, you have to make your mathematical statement. But sir, you make it look like English class. Well, it's a language, so you have to speak it. All right? Now watch me. Joe, you asked the question already, Joe? Sorry.
No, sir. I was just going to ask if you could go over the right-hand side.
Oh, the right-hand side? Okay, no problem. My pleasure. The right-hand side is, we're approaching 2. So approaching 2 from the right is going to be 2.1. Then 2.01. Go ahead.
Sir, could you draw the number line?
No. No. Just this one last time. One last time. I want you to get to a point, Crossville, that you, not just you alone, but the whole class, we need to start putting things into perspective. You know, press pause. Majority of you here are either IT specialists or management IT people them. Only do enough programming. Only know all the inside of the something work. And you can picture what a motherboard looks like. You can picture how a networking set up a network system. So I don't want you to create a disconnect with the calculus. The same thing that you do in your computing is the same thing that we're doing here. I want you to be able to visualize what it is that you're doing. It's the same thing. We use the same AND gate and NAND gate and NOR gate in a maths like we're not using a computing. Trust me. So I wanted not to create a disconnect. So look at it here now, pop up. I'm at 2 and I'm approaching 2 from the left-hand side. That means it's going to be 1.9 because 1.9 then 2. 1.99 closer. 1.999 closer. 1.9999 closer. and I can get closer and closer, incrementally close to the value 2, but I'm not touching 2. I'm getting closer and closer to 2, but I ain't touching it. And if only Adam did know overwork limits, we wouldn't have the problems we're having in today's life here. If only him could have do limits, we wouldn't have this challenge. What a nice world we're living in. But watch this now. Joe, you were asking about the right-hand side. I'm approaching 2 from the right. So I'm going to pull up to 2, but we can't pass 2. I'm going to get close to tell 2 some nice things. I love you. But I can't touch 2. So what is going to happen is, I'm going to go to 2.1. But we can't go back. I have to go forward because I try to get closer to this 2. So I'm going to go 2.01, then 2.001, then 2.0001 because I try to get closer to 2. I can't be at 2.1. And then my next guess is going to be 2.10 because 2.10 is going in the opposite direction. One goes so. Remember, now, look at it. If I go so, it means I get a bigger 2. But if 2 is right here, so I'm going to go so. When I go so to the left on the number line, I get smaller and smaller. Talk truth. Somebody say, you know?
Yes, sir.
Yeah, man. Yeah.
Yes, sir. Yes.
Yeah, good. All right, Joe. That explains it, Joe?
Yes, sir.
Mm-hmm. All right, let's go. I'm giving you one to do for me. And I just need to explain it. Have it as I do now. Sir. Sir.
Sir?
What is wrong with me? What is wrong with me? Come on, Sir Shan. Answer. Yes, please. Somebody say, sir. All right. Now, what is that thing? X extending to what?
Infinity.
Infinity.
What is infinity?
They're never ending.
No ending.
No, not never ending. It's a state that can't be accurately calculated.
What?
Sir?
Wait a sec.
I'm saying it's a state that can't be accurately measured.
Okay. Never ending is not, it's not a bad answer either, you know. Because if I say to you, name me the largest number you know, and you say 10, we can say, okay, 10 plus 1, 11. And if you say 1 billion trillion quadrillion, we can say 1 billion trillion quadrillion and 1. All right? So, infinity.
No noise.
Crossword, please mute your mic.
Sorry. So listen to what is happening now. When you listen to me now, when you listen to teacher, things nicer. What is a rational fraction? Anybody? When I say a rational fraction or a rational number, what is a rational number?
I think from what I remember, it's any number that doesn't have a decimal point or a fraction, or at least it's not a not a negative number.
Not a negative number. Okay. Anybody else? When I say a rational number, what is a rational number?
Sure, it's a number that you can deduce a value from.
a number you can deduce a value from. Okay. Anybody else? I like the responses that I'm getting. I like the participation.
What
All right.
about numbers that that in their original state you don't need to perform any necessary calculations to gain their accurate value? What about that?
Okay. All right.
Sir,
Yes, Talia.
is it like any fraction with like a non-zero denominator?
Ah. Tell Google, thank you.
Thank you.
That's the difference when pre-COVID and are we post-COVID or we are in a COVID? I don't even know.
So we're not in COVID anymore.
Trust me, I went to a function today that I totally forgot about. And I had to really sit down and look around. The person sitting beside me in the people them church never have no mask on. I must say, is it me or is it me? And when I look around, one or two they have it on, you know. And then now, when I left and went somewhere else, I had to turn to somebody and say, COVID I keep still? Because nobody now wearing a mask. Or they have the mask, but the mask is under their chin. But anyhow, yeah, man, you're right. So any number that can be written in the form A over B, is the ones I talk about A over B, any number that can be written in the form A over B is a member of the set of reals, and B not equals to 0 is a fraction. And that's what a rational number is. So rational comes from the word. What's the parent word of rational?
Ration.
Ratio.
What ratio means? When you speak about a ratio of something, when you talk about ratio, what comes to mind?
A division of sorry. Yeah, a division of numbers.
Okay, good. Give me an example of ratio. You're correct, but give me an example.
5 to 3 to 1. That would be an
Okay. All right, very good. Very good. So let me see who I can trouble in class tonight. Oh, and incidentally, your teacher is allowed to trouble anybody in class here. I am going to trouble Nicole because Nicole is going to come back to me. Since she was late for class, this is her punishment. So Nicole is very craven, very, very craven. Don't play with Nicole and her food. So Nicole buys her out a very large pizza. And I said, boy, Nikki, beg a piece of pizza now? She said, sure. You never asked her for piece of the pizza? He said, oh, goodness, Nikki. How much slices you have, Nikki? 16 slices you have. He said, all right, so one here. One, out of the 16 slices. Now, I can say to you, the ratio of pizza from Sir Shan to student Nicole is going to be 1 to 15. How many slices of pizza did she share? Did she receive in total?
16.
Right, because 1 plus 15 equals 16.
Mm-hmm.
And then now if Craven then from afar smell the pizza and say, no, sister, beg it 2 slices.
Mm-hmm.
Is that example like what Crosswell just gave? So, it's when they like a 1 to 2 to 13, because 1 plus 2 is 3 and 13 is going to be 16. So that's what it is. So ratio is showing you how things are shared. And how things are shared, it can be written in a fractional form to say 2 of 16 is 2 things that you're given out of 16. So once you hear the word rational, it comes from the word ratio. It means that you're sharing something. You're going to have a numerator, you're going to have a denominator. And as My good little friend, he said, don't remember her name. She said, with a non-zero denominator, because remember to say, zero cannot exist in the denominator. That's why we put b not equals to 0. B can't equal 0. You can't cross it because if you put some number divided by 0, you get math error. That don't make no sense. But now that you see, so it's once you have a rational function, once you have a rational function is just a function looking like this. A numerator and a denominator.
Rational function.
No. It is descending to infinity. An infinite large number don't have to be 1 million, gazillion, trillion, billion. It can be as simple as 10, depending on what it is that you're doing. As simple as 10. In these mathematical terms, once you're referring to rational functions. Once you're referring to rational functions, what do you mean, sir? Let's go. What do I mean is this.
Okay. Right to left. So 10. X are 10. Oh, Jesus.
Come on, man. That's just not doing. Okay. So this is what I mean. So I'm looking at the right-hand side. On the right-hand side, I'm going to start at 10. I'm using my right-hand side and I'm starting at 10. So you have to start at 10. No, you don't. But I'm just throwing a point here. These are just intelligent guesses, you know, that I'm looking at. Look, 10. Okay. So you're still using the intuitive approach. So you're just putting in numbers in there to work out to see if you can get the other numbers. Okay, got you, sir. So anywhere in the function, the rational function, I see x, I put 10. So it's going to be 10 over 10 minus 5. See here? 10 over 10 minus 5. Crosswell.
Let's repeat that, please.
I'm not going to answer.
Sorry, somebody will ask me to repeat what? Talk to me now, repeat what?
Mistake.
All right, Crosswell. You remember, is you were asking, sorry, or is Dane? Sorry, somebody was asking, sir, can you just show us
on the line?
Right here, so sorry, you never put the calculation inside here. So we were wondering where you get it from. I said, no, I'm not doing that. It's big school. You see, in this case now, I was trying to bring across a point. So look here what I'm doing now. You see that middle line that the person was asking about, see it right in here, so when you get to this time, because I could just put 10 and then 2 out here, so. But what is happening now? 10. So when x is 10, I'm going to substitute the value of 10 in the function. So I'm going to get 10 over 10 minus 5. 10 minus 5 is how much? 5. And 10 over 5 is 2. Talk truth. Yeah, man. And then now we're going to move to another number because remember, it's an infinitely large number we're talking about now, you know.
That's it.
So we're now going to move to 11 because 11 is not so much of a big jump from 10 to 11. So we're going to move to 100. Yeah. So I'm moving to 100. So it's going to be 100 over 100 minus 5. I'm going to be 1.05. Low, 2 and then 1.05. This don't look like it'll behave well at all. Make it go again. 1,000. Then we'll have 1,000 over 1,000 minus 5. And then we'll work it and we get 1.005. Hold up the man, hold up there. The one that the one, you know. But the one that was because the first one, yeah man, the one that we started before, the first one value kind of look biggish, but afterwards the second one it started to normalize. So we see 1.01, then 1.001. I'm going to guess the other one to be 1.3 zeros in there and they want 5. I don't know if that's going to work out, but I'm going to guess it because me see one little pattern I develop and I want to check it. So after 100, then come 1,000. So 1,000, we do that already. After 1,000 come 10,000. Come here, add 0. 10,000 over 10,000 minus 5. Low, see that true. Sir, we're not gonna further because if we do 100,000, we will get 1.00005. Talk truth. Now follow me.
Yes, sir.
And sir.
So, sir.
Come in, 1 minute.
Oh.
I'm coming, 1 minute. Which class I had before mine just now?
Administrative communication.
Oh, admin com, okay. I don't like the feel that I'm getting. I get the feel that, I now understand what one.
Understanding, sir.
Say it again.
Wait, I am understanding.
Oh, thank you, my love. Yeah, man, thank you very much.
So,
Sir, I don't understand.
You don't understand?
I don't understand either.
Me know. But me answer, no, tell me say I don't understand. I told me stop talk. I vex, me vex bad man. That's why me stop talk. That's why me tell cousins.
But sir, I said from before, so I not understand what I see, but I get you post, so I know what you did say after.
Oh, this Nikki? Madden, are you right?
Yes, sir, Nicole,
Yeah,
Madden.
man. Yeah, yeah, man. Me they call upon you a while ago, but maybe they get you out, yeah. All right. We'll say it one more time. If you don't understand me, we want to know if you tell me, say, sir, 1 minute, please, sir. Or raise your hand. I don't want to go through the whole question. And then he says, sir, I don't understand.
Sir, no more access, sir.
Go ahead.
It's because me to miss the first part of what you did I say from the get-go of the class, me not get home. When me can get the recording, so me can. Sorry about my background as the baby I cry. When would I be able to get access to the recording that I can listen to what you said the first class and try to see if I can understand what you have been saying?
Okay. All right. Tell me nieces and my nephew say they better take out them calculus one book and be quiet because I'm teaching and I'm supposed to be making notes.
So one thing about me, I should tell you that my background is always noisy. Sorry, I left that out from the get-go of the class.
Okay, all right, then cool. All right, so the recording will be sent as soon as the recording is made available to me. So as soon as the recording is made available, I will send it. I can't tell it's going to be immediately after, maybe a day after, whatever it is. Anybody saw the other recording, the first recording?
No.
No, sir.
But sir, being that you are the host, you wouldn't be able to on your device be able to get the recording directly. You'd have to go through different channels before it gets to you.
Yes, ma'am. It is sent to me. So I may be the host, but the institution Excelsior College is really the host. So Excelsior has many licenses. So they are the general host. So when it comes to them, depending on who the class is assigned to, the system automatically sends it to those lecturers. So once it becomes available, because remember the class will have to be downloaded, So when I'm using my personal Zoom as a host, because it's my personal Zoom, whenever the recording is downloaded, that's the time it is pushed to me. So because we're having night classes now, and all these recordings will have to come to Excelsior, it may take a little while, but as soon as the recording comes, I'll put it. And incidentally, the recording for the first class was already uploaded to the YouTube channel. You can check. All right, let's go again. In essence, what I'm doing.
Sorry. You said the first recording was put to YouTube channel?
Yeah.
To your YouTube channel?
Yes, please.
Okay. And so you sent a link to that channel in the group from the get-go?
Yes, please. It's in the description for the WhatsApp group. Are you part of the WhatsApp group?
Yes, I am. I probably missed that information, or I didn't remember when you had made that notification.
Okay, yeah.
Now,
Look in the
can somebody
description.
just repost the link? I didn't
No,
get
enough for repost, not man. Just look at the description and you see. Yeah, man, in
Okay,
the
then,
description.
sir,
Yeah,
no
man.
problem. I will.
Cool. Yeah, man. All right, so let's go now. I'm gonna start again in layman's term. Work with me. So what I'm saying to you is, when we're using the intuitive approach is developing a relationship with the limit, recognizing that the limit is not the number itself, but it is approaching that number. You're approaching that number. So you need to investigate what is happening from the left-hand side, and you need to also investigate what is happening from the right-hand side. The investigations, once it is that both values, the result from the left-hand side and the result from the right-hand side are the same, you can confidently say that the limit exists. If I two different things you get, the limit does not exist. Let me put it in layman's terms. You go to one doctor, and the doctor say, you have an ear infection. I said, me not think me have an ear infection. I'm going to go for a second opinion. And I go to a second doctor, and the other doctor said, no, it's not an ear infection, you know, it's that you went to the pool and there's just a little water in the ear. So let me syringe the water and you will be fine. And then they say, you know what? I'm going to go to one third doctor. And then the other doctor says, no, it's not an infection. It's just a little fluid that is in the ear. So let me just syringe it and get it. Say, okay, fine. Then what you're going to be doing now, because two of the answers come out to be the same, you're going to throw away the first. So the first doctor that says it's an infection, you're going to throw it out. Right? And this is why people get second and third and fourth opinions. Same thing with lawyering. All right? Is what it is that we're doing right here now. My intuitive approach is to see what is happening with the limit. It says the limit is approaching 1. I'm investigating, looking from 1 from the left-hand side. Now, from the left-hand side, my initial guess is going to be 0.9. Then, sir, you could start at another number. Yeah, but if I start at a number, no, that's not the closest to 1. If I start at 0.5, look how far 0.5 did. 0.5 not close to it. 0.5 far from it. So what I need to do is to get something close. So I'm going to go to 0.9. But I recognize, watch me. Watch the position of my, I'm going to put on the spotlight. 0.9 is right here. If I go this way, I am going to go away from 1. See 1 right here, so? But if I go this way, I'm going away from 1. 1 is here. I want to go towards 1. So I have to go to the right. See here, from the left is moving to the right, and from the right is moving to the left. So when I go to 0.9, the next number I have to go to is 0.9 something, because of that direction I'm going to go over here. So that makes sense?
Yes, sir.
Yeah, man.
Yeah.
That's why I go to 0.99. Then so you're going to go to 0.95. Why am I go to 0.95? And we can go to 0.99. Because 0.95 is a smaller number than 0.99. Talk true.
Yes, sir.
Yes, sir.
All right, you know. There are some students in this class that I'm going to mute. The ones that always talk to me. And then I'm going to see what other students in the class will do. Yup. Good to go. Yeah, all right. I know exactly what I'm going to do. I bet you talk to me. All right, let's go. And then, no, let's tell you, go ahead.
So remember when I was telling you that I don't understand?
Mm-hmm.
I get it now. I was doing it wrong.
Nice. Nice. Trust me. You remember I them open wide up. Yes, please go ahead.
Yes. You said on when we get the same answer from the two from both sides, that's when we've reached the limit, right?
Yes, please. Very nice.
So I'm kind of wondering from the beginning now for this example, 1.9 and 2.1, they actually are the same. So why do we have to go further?
1.9, 2.1. Okay, so you're asking the question. So 1.9 and 2.1, they are the same?
Yeah.
So you're saying, why did we have to go further? Okay, fine. Excellent question. So clearly you are one of our foreign students. Talk to me.
Yes, sir.
Okay, and how do you pronounce your name, please? I'm Christian and I don't want to curse. How you pronounce it?
It's Oluwapalumi, but I prefer being called Courage. That's my middle name.
Oh, you're called Courage.
Yeah.
But I still want to know. Give me the pronunciation of the last one. Last name.
Igwebike.
Igwebike.
Yeah.
Okay, Igwebike. All right. Good. You know, I'm going to teach a little Jamaican culture because you can't come to school of Jamaica and don't get piece of our culture. And I'm going and me not going to tell you, you know, Lottie, come on me for me, please, Lottie. I'm going to put you on spot. All right, Lottie. When you go to market, you see, and you say, how much a pound for yam? And them say $200. The first money you say, I say $200. You go buy it?
Work out the whole of the market.
No.
Oh no, Courage. Sorry. Oh, you mean no? I don't understand. But when you say no, Courage, tell me.
Because I want to check if there's a cheaper one.
Okay, so you just answer your question then.
Yes, Courage.
Okay.
You just answer your question. Very good. Because, you know, well, like all me, you know, when me go market, one time me go market, you know, me said, no, me go put on good clothes because me no want let how you see me out of road because you say, me see church and a market, you know, and the man, you know, one piece of tear up jeans, me say, me couldn't believe some teacher. So, you know what I do? When I put on good clothes and go market, I say, much a pound for this? $500. I said, so much money? I became go to the supermarket. And then I go around the road and I say, Bridget, how much for that? I say, you know, 150. They say, oh, me get the trick. So the man them look for you. So I say, hey, watch this now. So I start, look like me go to the market now. And me get the right price. So Courage, you're correct. So you can't, you enter the market. How much a pound for the yam? $200. Okay, thank you. You know, I get it cheaper enough. That's all right. Don't worry about it. And you go into the market now.
Yeah,
and you may hear say it's $200. Everybody may have it for $200 a pound, you know, but that's fine. But you can't just use the first one, Courage, to say, and this is the answer. You have to investigate. So this is what Latoya do. She walk into the market and them say $200. And she said, okay, fine. And she walk and say, blow, the yam dry. She said, the yam nice, man. Where it come from? And them say, Trelawney, are you saying Bolt yam? And I say, hey, how much a pound? And then you get something. I say, all right, fine. I go walk, you know, from my market person, I buy the yam from. If them not have it, I go come back. And you run go a market person and say, how much for that? $200. And I say, all right, guess what? Guess what? Me don't know that $200 pound in the market. Which one of these is the nicest looking one? And you go back to your friend and say, all right, are you saying Bolt yam I want? Fine, boom. Then this is the left-hand side of the market, and you go by the right-hand side of the market, and you go ask the same question. And you know, you have left-hand side and right-hand side of the market. You have the people that on the outside, and you have the people that on the inside of the market. Eh? Good. So you go into the market now, and the man them you ask the man for the stuff, and the man them say $200. You say Rockstone. Guess what? It's one of two things, you know. Either not go eat no yam for the next 2 weeks because you not pay $200, or you're gonna just buy the yam, short yam, just buy 2 pounds of yam. Because you want like a soup. All right. Good. So you can't just use one. You have to use a series. So this is what came back to the question that was asked. Sir, do we have to go to 4? Maybe Courage. You could stop at 3. You could have stopped at this one, and this one, and not necessarily do this one because you could use by hypothesis that the pattern that you're seeing so far is that this one would have been 1 extra 9. Let me ask you a question. The next one in this sequence would be what? Tell me, 1 point how much 9?
That's nice.
Very good.
1.9999.
Very good. Excellent. So you're looking at, so you can't just use one to you know, it's just like me. I can't come to class and say, at the first class, I don't like the class because me ask them question and they not talk to me. I have to give you other opportunities. Now, when by the time you reach the fourth class and you not talk to me, you know, what's going on the daylight? And say, no, go on in the yard. But sir, we are at home. Darn, I have to go find something else and tell you, right? But I don't even get the point. Madden, Nikki, you understand this now? Watch, I should go on again. All right.
Sir?
You understand it now?
Must admit I wasn't paying attention for the last one.
Okay.
And you just did.
Have a wonderful rest of the evening. All right, let's continue. So if you look at this one here now, this function is the same sort of procedure that we are going to be working with. It looks different because this one is tending to infinity. Infinity is just a concept, and I don't want to let the foot out of the bag just yet because I'm still teaching the intuitive approach. But infinity is just a concept. And whenever you see infinity, whenever you see the limit tending to infinity, there is something that you must do.
Think that what, sir?
When you see the limit tending to infinity, there is something that you must do. What is that?
Okay.
Yeah, do. Yeah, D-O. What is that, sir? I'm not telling you. That's a little secret for now. Have enough time to have enough time to tell you what it is. So look at what is going to happen now. Anywhere, I'm guessing 10 to be my my first infinitely large number. And let me tell you, so when you have a rational function, 10 is an infinitely large number. And we're going to get to there. You will see all of this is going to unravel sometime soon. Anywhere in the function I see x, I'm going to substitute 10. 10 over 10 minus 5. 10 over 10 minus 5. 10 minus 5 is 5. 10 over 5 is 2. Okay. So you said to yourself, courage. You see why we couldn't even use the first one again, because the one is a 2, and the one over the other side here say
0.6.
Say
Yeah, I saw that. That's why I asked the question before.
Okay, very good. Yeah, man. That's why mathematics nice, you know. It is so logical, right? All right, let's continue. So you know you can't use the first one alone. You have to go through and find out exactly what is happening. So what you're going to be doing now is moving to the next infinitely large number. So we can use 11. It is so close to 10. Let us jump a little bit more now. What about 100? We jump to 100 and we work it out and we get 1.05. And then you say to yourself, wow, 2, 1.05? So far, this is not behaving nicely. I need to investigate even further. You jump to 1,000 because you're increasing your numbers now. When you jump to 1,000, it works out to getting 1.005. You say, aha, I'm going to make an intelligent guess that the next series is going to be 1.0005. So in your headspace, that's what it is that you're saying to yourself. But we now need to investigate it. So we're going to say, this is 1,000. We're going to say 100,000. I mean 10,000, because we're adding a 0 to it. So it's 10,000. So 10,000 over 10,000 minus 5. And you say, voila, my guess was correct. We're not going further. Because guess what? I am seeing a pattern. 1.05, 1.005, 1.0005. So what can you say that the limit on the left, on the right-hand side is tending to?
1.
1. Very good. It is tending to 1. Now we need to venture over to the left-hand side. And if it does 10 to 1, it is of a good behavior and the limit exists. If not, bad behaving child, the limit does not exist. So let us
sir.
investigate. Go ahead.
So I was wondering if how both sides, the left and the right, is equal to each other. So by virtue of rounding off, so 1.05 is equal to 0.95 because both can reach to 1.
All right, Dan. I don't want you to, you use a word that is uncomfortable with me. You say rounding off. I don't want, when we're calculating the limit of a function, we're not going to round off, you know, because the limit of a function is the, you see, if you're supposed to put in, how do I say? If you're supposed to give a person a particular medication and you say 0.95 centimeters cube of a medication is supposed to give to the patient, but you say, sure, 0.95, when you round off, you get 1, and you give the patient 1. What can happen to the patient?
They could have complications when they get the drug because they're not getting the recommended dose.
It is a 4-letter word. What will happen to the patient?
Die.
Dead.
Dead. Dead. Why? Because, and I'm answering Dan this way because I want to break that cycle from now. And this is why I love when students talk to me in class, and because I'm able to, it's a teachable moment when I hear these questions. As students, we love the opportunities to round off. We love the opportunities to round off. But I'm saying to you, in this rare case, Dan, you're not rounding off enough. You remember, you know? Let me ask you, Dan, unmute for me, please, son.
Me? All right.
Yeah, man. You're unmute?
Yeah.
All right, do me a favor, Papa. Read this for me, please. The limit as
Extending to infinity.
okay. Give me another word for tending.
Going.
Another word.
Approaching.
All right. Work with me now, Dan. The limit is 2, 1.05, 1.005, 1.005. What will my statement say? We say that it is of a good behavior since the limit what?
Approaches.
Approaches 1. So am I rounding off?
No, sir.
No. So the limit is approaching 1. All right, let's go. Let's continue.
Sir.
Yes, Papa.
Yes, sir, I appreciate that, but I was wondering if the left side can be equal to the right side because I heard that Courage said that 1.9 is equal to 2.1. I was like, oh, that don't make any sense to me.
You did sleep a while ago, you know, because we did go through the part there. What she was saying here is when you round off, which is the same question that you're asking, Courage says, sir, when you round off 1.9, you're going to get 2. And when you round off 2.1, you're going to get 2. So why did we have to go through the rest of these? And I said to her, we are not rounding off. And I said to her, you can't even use one thing to judge what is happening. You have to go through a sequence. I saw come the YAM argument, they come in. So I'm saying to you, if you look at this here example, 2 and 0.6, when you round, well, this is a whole number, but when you round that one, you're going to get 1. And the two of them are different something. So you will say to me that the limit does not exist if you're going to be using these alone. Follow me what I'm saying, Dan?
Yes, sir. So you test the limit of a number or the function if you can round it off and the two sides the same.
Hey boy, let me tell you something for a sec. Somebody tell him which word I don't want him to talk about.
Round off.
Rounding off.
Which word we can use?
Approach.
Approach.
All right, continue now, Dan.
All right, sir. I don't understand how to use approach in that context.
You don't understand how to use approach? You're making this complex, Dan. What you don't understand into making this approach? In terms of what?
Testing the limit of a number to see if the two sides are equal.
All right. When I put this as -10 and I put it in the sum thing, we get 0.6. When we use -100, I'm gonna put another function, we get 0.95. When we put -1000, put another function, we get 0.995. We put -1000, 10,000, and put another function, we get 0.9995. This value then is approaching what number?
1, sir.
Good. So how is it enough to use the word approaching in the sentence? What I don't want you to say is that you're rounding off. Because when you move into other aspects of the calculations method and you get a value, you are going to say, but when I rounded off, sir said that I was correct, and I am going to mark it wrong.
So, sir, can I ask a question?
Go right ahead.
In these type of questions, is the case there, the left and right side must have an equally approaching result?
Yes, sir.
Okay.
Yes, sir. That was the essence of my question.
But I were answering the essence of your question all along, sir.
Yeah. I just wanted to know if it's a case that it must always, if it was always do it. Because no, wait. In my assumption, I just assume, like, say there would be questions in the future that would force you to say, like, say, this equation cannot be solved or something similar to that vein.
All right, no problem. I think the Lord gave me the most perfect answer for you.
Referring to me?
To hold on.
Oh.
When you buy something like one phone or one computer, one gadget, or one even storage device, and them say it is 1 terabyte. No, terabyte are big something. Me never study computer, so me know them big something there.
Oh, you can use a terabyte as an example.
We know you can get a terabyte something, but let us use
256 gigabytes. Just use that.
256 gigabytes. Okay, so let us use 256 gigabytes. In essence, sometimes it's 240 something gigabytes you get.
Yes, because some of it has to be used for partitioning.
Okay. So you see the point I'm making, Dan? So even though you're paying for 256 gigabytes, you really now get 256. If you're going to store something for 256, now go store. Tell me, say get the part there now.
Yes, sir.
No, you don't get it. We don't like the answer there. We're moving on though. So we're saying that it is of a good behavior since it approaches 1 from the left and the right, right? It approaches 1. Because if I continue this sequence, -100,000, -1 million, bam, 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 I'm going to get 0.999999995. That value is approaching 1. We're not rounding off. It is approaching 1. Rounding off is too general a term, and I'm very cautious with what I'm saying because it's going to come back to haunt us. All right, let's go. So that was the intuitive approach. I'm going to show you now what the calculations method looks like. And again, I'm going to be very cautious with my words. So I'm looking at the calculation method.
Okay.
Or if I want, I can call it the algebraic approach, because sometimes by algebraic, because sometimes I have to do some sort of processes inside of here in order to reduce my limit. And algebraic, because sometimes inside of here, so, or when you put in the 5 inside of here, so you're going to get 0 up on your, so you're going to get 0 down here, and you know, so the limit is not 0. Right? So then now we have to go do some algebra. We still a calculations method, you know. But in the calculations method, we can have some algebraic stuff to it. All right, work with me. This may be the nicer part. So the limit as x tends to 5, the limit as x tends to 5 of x plus 1 over x squared. When you're doing the calculations approach, my choice of words are very important here. When I'm using the calculation approach, I am going to assume that x is equals to 5. Sir, why not just say x equals 5? I'm assuming that x is equal to 5 because me not see no equal sign right here. So what does sign say it do?
You're approaching.
It is approaching 5. So me can't tell the people them say equal 5. It is
Sir,
approaching 5.
Sir?
I try.
No, hold on, Crosswell. Go, Joe.
Sorry.
Sir, this is what I was doing to why I got 4 for the first question and not 3, you know.
All
So
right,
that is what I did.
No. We're coming back to that one. We're coming back to that, Joe. We're coming back to that one. Go, Crosswell.
Yeah, 'cause when I first saw number 1 for the algebraic approach, I try using 4.99 as the cause that is closest to 5, and when I tried using that as x in both values, it didn't reach the conclusion that is 6
that I have right here.
Yeah.
Because as I said, courage, ask a question. You can't just do one Crosswell and read it. You have to do a series of them to see what it approaches to. If you're using the intuitive approach, now hear me out. The intuitive approach is what I have to teach you. But when you get in a question on limits, if them don't say to you, by using the intuitive approach, no use it, because it's gonna take long, because you can't do it one time and get the answer. You have to go do it multiple times in order for you to see the trend, to say what the limit is approaching to. It's a concept, you know. It's a concept. It's a concept that you have to go get. When you're using the calculations approach now, you're saying to yourself, you are allowing the limit to be equal to that value.
Okay.
It is not equal to it, you know. You're just going to assume that it is. It's an assumption. So for the calculations approach, I am going to assume, because it says to me the limit x tends to 5, but I'm going to assume that x is equal to 5. When I assume that x is equal to 5, 5 plus 1 is 6, and 5 squared is 25. Now, this is the limit of the function. The function can't get any bigger than this. That's the limit of the function. Similarly, the limit as x tends to 0 of x squared plus 5 over x minus 1. I am going to assume that x is equal to 0. 0 squared is 0, 0 plus 5 is 5. 0 minus 1 is minus 1. 5 over minus 1 is minus 5. Oh, sir, I catch it now. So you're just going to assume, say, the little number on the bottom right here, so you just go substitute inside here, so and that we are doing, you know. Make a check one next one. The limit as x tends to -4, so I know what to do. You're going to substitute -4 anywhere you see the value of x. Very good. So this is going to become -4 squares Negative 4 squares, it means that it's negative 4 times negative 4. Negative 4 times 4 is 16. And when I multiply two negative numbers, I get a positive number. So positive 16 for the numerator. Very good. Negative 4 minus 4. Sir, negative 8. Very good. Positive 16 divided by negative 8 is equal to negative 2. Sir, we can try one more. All right. And I was very nice to break out this one. This one says the limit as x tends to negative 1 of x minus 1 over x minus 2. Look what sir doing. Sir is assuming that x is equal to negative 1. Anywhere in the function I see x, I'm substituting negative 1. Negative 1 minus 1, see that so? I'm gonna put it in a blue. Instead of blue, the blue negative 1 here, other 1 here, another 1 here. Now. The blue corresponds to the blue. So anywhere in the function I see x, I am putting negative 1. See, Jonas again, negative 1 minus 2 is negative 2. Rubbishness. Negative 1 minus 2 is going to be negative 3. And negative 1 minus negative 1 is going to be negative 2. So I'm going to have negative 2 divided by negative 3. Press pause. Daniel, son, unmute for me, please.
Yes, sir.
All right. If my teacher don't want you to do not rounding off, because if you put this into your calculator, you're going to get 0.666666. True or false?
That's true.
Mm-hmm. And you may be tempted to do what, Daniel?
Round off.
Round off and call it 1. And if you give me 1, your question wrong. I'm going to mark it wrong. So rounding off, you can get a fractional limit. You can get a fractional limit. So I don't want anybody to talk about no rounding off business. It is approaching something. All right? Okay, very good. Now, then, sir, there's something them this easy, and I got with them long something here.
So
Because
how you get the
Sir, can you go back down to the last one?
I see you have the fraction in red now, and you remove the negatives.
When I divide two negative
Cancel the
numbers,
negative.
right? When I divide two negative numbers, I get a positive number.
You just okay.
Yeah. When I divide two negative numbers, I get a positive number. When I multiply two negative numbers, I get a positive number.
Okay.
Yeah, man.
Let me jot it down.
Yeah, man. Every time.
I divide two negative.
When I multiply or divide two negative numbers, the answer is positive. Yesterday, today, and forever. I can move now, Joe?
Yes, sir, you can.
Yes,
all right,
sir.
good. All right, nice job. All right.
Sir, hold on. Give me a second, sir. Hold on.
Go ahead.
So, 0.
You can go ahead, sir.
0 times 0, 0 plus 5.
Sir, you can go ahead.
Okay, no problem.
So.
Sir, I have a question.
Go ahead, Papa.
All right, so for this approach, you would always have the limit of the function at the other side so that it can replace x, so that it forces you to say x is equal to the limit to 5.
Yeah.
You can repeat it?
Ask me the question again. Which one are you talking about? Which one are you referencing?
Sir, I'm referencing to number 1. So, so sorry, sir. I'm wondering if for like on a test, you're going to see the limit of the function on the other side of the equation. So it forces you to think that x is 5 at number 1, for instance.
My question will say, evaluate the following limits.
Yes,
question,
Okay, sir.
go ahead. Am I understanding what it is that you're saying? So look, the question would be, remember, no, I'm not putting it, okay, what I'm doing is I'm giving you the stuff in bite-sized pieces. So there are several moving parts to the question, and I'm attacking each moving part in such a way that when all the moving parts are stationary, I can then put the puzzle together. So you notice I'm looking at the intuitive approach, and then I'm now looking at the calculations approach, and then I was going to go back now before I was asked to stop to show you something. Because two things. Thing number one is, when I asked you to evaluate the limit, me wants a one or uno. Go use the intuitive approach. Because the tests I got done, and I'm not finished the intuitive approach yet. Then, sir, why you teach it? Because you must understand what the intuitive approach is talking about. You see how long me and Daniela fight? Sir, round off, don't round off. So why approach? Why not equal? Because it's a concept that must be ingrained in you so that you can understand what is happening. And I try to teach conceptually so that, and I may be taking, some of you may be frustrated and say, Lord, sir, move on, I understand. Yeah. But it's when I teach conceptually and you understand the basic stuff, it means that next class I don't have to go back through the something. All right, watch me. So if the question said, evaluate the limit, and I'm going to use my calculations approach. X approach is 1. I am going to assume X is equals to 1. What is 1 plus 1?
2.
See the answer there?
2.
Done it long time. Make you try that one, you know. X approach is 2. I'm going to assume X is equals to 2. What is 2 plus 1?
3.
And what is 2 minus 1?
1.
What is 3 over 1?
3 over 1.
3.
3.
No.
Excuse me? 3 divided by 1
3
equals
over
how
1
much?
is 3.
3.
3 over 1 equals 3.
Yeah. Sorry about that, sir.
Fraction. 3 over 1.
Approach is 3.
Fraction.
That's what I'm saying? That approach is 3. Then,
Sir,
sir.
your question. So for this is where I went wrong. Because for this one, I was using the algebraic approach instead of using the other one. That's why I got 4 instead of 3.
But I want to know where you get 4. Tell me where you get 4 out of that. Can you substitute 1 in?
Sir, I did explain it, sir. So what I did was that I substitute X for 2. Yes, that is what I did.
Yes,
And
but
I
funny
got
about you. But we want you tell me how you end up getting 4, because if you substitute X for 2, which is what you're supposed to be doing, 2 plus 1 is 3.
Sir, and then the 2 minus 1 from 2 is 1. So I would get 3 over 1. And when I did that, I had the 0.9. I never put 1.9. I never put 1.9. That's what I'm saying. I never use 1.9. I use the 0.9, and then I add the 3 to the 0.9. And when I round it off, I got 4.
Okay. You remember that round off something story we're talking about?
Yes, sir. That's why I got it wrong.
Right. Stay away from the round off something. Sir, no.
The approach then.
Yeah. Sir, we can't use the
infinite.
Yeah, for the infinity part, sir. So we're going to substitute in it to get it. That's a special case. And I'm getting into that special case now. Can I just stop you and tell you a secret, please? Anybody want to hear a secret?
Yes, sir.
What time is it?
9:23.
What time is it?
9:24.
9:24. You remember when I said to you that we need to go to from 7 to 10? People are talking 7 to 10, sir.
We reach 10, I will not even know.
Which is the point I'm making. We're almost at the 10 o'clock hour, and I mean, I am watching the clock. So I know when it was minutes to 9 o'clock. But see, it's almost 9:30, and you're still in class and you're not feeling it. Anybody feeling it? Don't say yes.
Yes.
Tell me. I'm feeling it.
Sir, from 9 o'clock coach.
From 9 o'clock, come here and feel it. Put it this way. You're going to have 11 more weeks of it here. All right. Go ahead.
Yeah, no.
No, sir. No, someone more asking a private, sir.
Okay. All right. Now, so the story. I'm going to end the class with this story because since I showed you the intuitive approach, and I also showed you the calculations approach, and show you, say, boy, I can use the calculations approach. I can use the calculations approach, and still verify that my answer for the intuitive approach is correct. So how can we verify that this piece here that we get to be 1 is correct? Thank you for asking. You shouted so loudly at me that I'm so happy that you asked. So I'll soon answer you. Soon come back to that one here. So I'm going to be looking at my indeterminate form. My indeterminate form. My indeterminate form in this particular case is going to be 0 over 0. My indeterminate form in this case is going to be 0 over 0. Work with me. So we understand the intuitive approach, and we are now very versed on the calculations approach. The calculations approach says the limit is tending to 3. You are going to assume that x is equal to 3, and anywhere in the function you see x, you put in 3. Very good. See here, applying the algebraic approach or the calculations approach, same difference. Anywhere in the function you see x, you put in 3. 3 squares minus 5 times 3 plus 6. See it right here, so. And 3 minus 3, blow. But 3 minus 3 not equal to 0. But sir, this is something about rational function on a over b is a member of the set of real numbers, but b is not equals to 0. There is no way. Tell it, Google it and tell me. Remember that. B can't equal to 0. See it right here, so. Then, oh no, we have this one question. We will know so the denominator equals 0. I'm going to work out the numerator. 3 squares equals 9. Negative 5 times 3 is negative 15. And the 6 is a standalone. And 9 minus 15 is negative 6. And negative 6 plus 6 is equal to 0. Reason. So the answer is 0. 0 over 0 is how much again? 0. So the answer is 0. No, it's not. So we have to do something else. So whenever we get the indeterminate form, it is telling me there is something inside of the function that is preventing the true limit of the function to come out. There is something inside of you, student, that tells me that you are a very good student, but there's something that is preventing it. Show me your friends and I tell you who you are. Watch me. I recognize that my numerator can be, and when I get this indeterminate form, it's one of 3 things: a simplification, a factorization, or a rationalization. So I'm going to simplify the function, I'm going to factorize the function, or I'm going to rationalize the function. So it's either a simplification, a rationalization, or a factorization. One of the 3 little things that we need to do in order to isolate what is preventing the true limit of the function from coming out. Watch me. I recognize x squared minus 5x plus 6 is factorizable. So I'm going to factorize. See that, so? This up here, so numerator I'm using on it. The denominator for me is in its simplest form. The numerator, being a quadratic expression, can factorize that quadratic expression. So I'm going to go ahead and do it. So, yes, I turn up now, Jesus.
Quadratic equation.
No, formula, expression. You make now equal sign.
Yeah.
It becomes an expression.
Well,
watch me now. Go ahead.
No, we'll wait until you finish.
Okay. So I have my quadratic expression, x squared minus 5x plus 6. So where you get that from? From the question. And it's the numerator of the question that I'm going to be factorizing. Remember, I said to you, once I do my question and I get the stuff to be of an indeterminate form, it is saying to me that there's something in the function that is preventing the true limit of the function from coming out. What will I have to do in order to get that out? Either a simplification, a factorization, or a rationalization. One of the ons that we need to do, simplification, factorization, or rationalization. One of the three, this is something that we need to do. In this case, we're going to do factorize. What is the coefficient of x squared there?
Coefficient of x squared.
True, sir.
Anybody else? What is the coefficient of x squared? Let me spotlight.
Say, can I write it down?
What is the coefficient of x squared in this expression? See, my spotlight is by the expression. What is the
Sir.
coefficient of x squared in the expression?
Sir, 6.
1. Coefficient of x squared is 1.
Why?
Because in any case, if this was supposed to be a regular algebraic expression,
Tell me why. You say 1. Tell me why.
because that is the default value that is given to unknown variables in regards to quadratic expressions.
Sir,
What
I
is the
say 6
coefficient?
because 6 stands alone.
6 stands
Yeah.
alone. Okay. Okay. All right. Fine. What Crosswell? What is the coefficient of x?
Coefficient of x 1.
Ah, that's why I asked you the question. That again, they're saying no. It means to know that your theory is not correct. What is a constant term?
The
Sir,
constant
X.
is x.
6.
The constant term is
6.
X.
all right.
Once I broke it down into the second formation, it's mostly x squared minus 3x minus 2x plus 6. And the most common term in that expression is x.
So the constant term is what?
6.
Sir, X.
Or can it be
And Joe, you're still holding on to x, Joe?
Sir, no. Sir, Mr. the rank now.
All right. What's a constant term?
6. It's constant.
Why is it 6?
So actually, I don't really know why, because from
No, you were so confident a while ago. 6.
I'm saying because
No, man.
it's
You gave-
alone and
you-
it's
It stands alone.
You gave me the 6 with a quantitude. 6. So tell me why you say 6.
Sir,
Incidentally,
can I
you're
answer?
correct. Go ahead.
Sir, it's because it doesn't have any variables beside it. Sir, it stands alone.
It stands alone. All right. Say it one more time. Let me hear you.
So because 6 stands alone.
Okay. All right. Because 6 stands alone. And that will be correct. So 6 is a constant. 6 is not affected by anything. Him just going to be like that. You know, 6 is not one of them who can listen to no gossip and swell up or swell down. 6 is just 6.
That's it.
Let me ask my original question. What is the coefficient of x squared?
So let me see now. If 6 is a constant and x is and x squared is a coefficient, there will still be 1, because 6 in any case should be a separate entity and not be affected by any of the other factors.
Sir, the coefficient is 1.
What is the coefficient of x?
Sir, 1.
Sorry, isn't x
Is
equal
it
to
2?
3 in this case?
X equals 3? Why you get 3, Daniel?
Well, sir, because in the first algebraic approach, you had put 3, substitute x for 3.
Oh, no, wait, we don't reach this yet, man, Papa. We don't reach this yet, man. I'm asking a question. I'm hearing an answer, but when I ask a follow-up question, I'm hearing an incorrect answer. So it means that the first answer is a guess. So I'm asking now, what is the coefficient of, listen to me. I am not one of those teachers who come to teach, so you can just go and just belt your farms if on one paper here. wanna have to understand the mathematics. What is the coefficient of x?
So 2.
Sir, the number that comes before the variable. So it would be -5.
Tell Google, thank you.
Wait, so wait.
Sir, who said I use Google?
Wait, sir, hold on. You were
Sir,
asking.
who said I use Google? I look in my old pre-calculus book, sir.
So wait, sir. I have a question.
Well, okay, hold on. So tell your pre-calculus book, thank you.
No
So
problem.
wait, I have
Thank
a
you,
question, sir.
pre-calculus book.
When you mention x squared and x, you're referring to two different
terms. Say terms.
Terms, yes, two different terms.
Yeah.
So I didn't realize.
So you notice what I said? It is known as a trinomial. Can you see what is called a trinomial? Let me help you. One term is x squared, that's the first term. The next term is -5x. And then the last term is +6. So it's called a trinomial. People call it a quadratic expression, but this quadratic expression is known as a trinomial. Just like when you have a quadrilateral, you have many quadrilaterals: square, rectangle, kite, rhombus, parallelogram, trapezoid, you name it.
Okay.
It's just that the broad family of a quadrilateral is under a four-sided figure. But you have many of those. So this one has many names. It's a quadratic expression, but it is a little bit more than a quadratic. It is a trinomial. So thank you, Joe. Coefficient means the number in front of. So what is the number in front of this x squared now?
Sir, -5.
No, we say x
Sir, sorry,
squared.
1.
Good. And what is the number in front of this x?
-5.
-5. So Crosswell, so you understand when you gave me 1 for the coefficient of x squared enough. And I said, before I tell him that he's correct, I need to ask him about the coefficient of x. Because if he says to me -5, that means I know him understand, but you are giving me a different answer. So I said, no, that's a yes.
I wasn't properly listening to the question.
All right, cool. All right. So remember now, so when I speak of a coefficient, I'm speaking of the number in front of. Why am I taking so long on this? You see them little calculation right here, so the piece right here, so it'll go come back to haunt us when we move on to stationary points. When we move on to stationary points, it are going to be there to antagonize us. All right, so let's go. So I'm multiplying the coefficient of x squared by the constant. 1 times 6 is 6. And I need two numbers. When multiplied together will give me 6, but when added will give me a -5. And those two numbers are -3 and -2. Let us check. -3 times -2 is 6, and -3 plus -2 is -5. So I would have found my factors there. When I group, I'll put in them two here, so in one bracket, see it right here, so x squared minus 3x. I will leave my middle sign out every single time. Because if my middle sign is not left out, it means that is this multiplied by this. So this sign here, the middle sign, must be left out every single time. And then I'm going to group these other two pieces together. But when this middle sign is a negative sign, we need to flip the last sign. So you know that this sign here is positive? We need to flip it so it becomes negative. Sir, I was never told that we need to flip the sign. Why did we flip the sign? Okay, thanks for asking me. When I distribute this negative sign over this +2, I'm going to get a -2. See it here, so? And when I multiply this negative number by this negative number, I'm going to get a +6. See it right here, so? So once the middle sign is a negative sign, the other sign must be flipped. Here what happened also, just to show my point, to prove my point, whatsoever sign is in the first bracket must be the same sign that is in the second bracket. So I couldn't have this sign as negative and the sign each up in here as positive. Can't work. They must be the same signs. Work with me now. What is common here that is common there will be x. What is left? It's going to be an x. Sir, how you know? Because when I multiply x by x, I'm going to get x squared. What is common between this x? So what is left here when I take off the x, it's going to be -3. Why? Because when I multiply x times -3, I'm going to get -3x. So I'm factorizing and I'm able to factor out an x because x is common to here as well as here. In this here case, what is common between 2x? My middle sign is left out still, you know. But what is common between 2x and 6? 2. Because 2 is a factor of 6. And 2 is a factor of 2. So I'm going to factor out my 2. So it now becomes a -2. What do I multiply by -2? To give me this value here. It's going to be x. And what do I multiply by this? To give me this value here, it's going to be -3. Watch me. Whatsoever is here must be the same thing that is here. And then now I can factor out what is common. What is common between these two terms, x times x minus 3, and 2 times x minus 3 is going to be x minus 3. So I'm factoring it out. Boom, x minus 3. What is left? When I take off the x minus 3 from here, what is left is x. See it right here, so. When I take off the x minus 3 from here, so what is left is my -2. See it right here, so. So what I would have done is to factorize my x squared minus 5x plus 6, this, right here, so, to now give me x minus 2 times x minus 3. So I'm going to substitute the factorized term. You notice I didn't ask anybody if they understand right here, so? Because I know you don't, some of you. But that is going to be your homework. So I'm not going to spend the rest of my time to go through this. I went through it because I want to pick up this final answer as x minus 2 times x minus 3. So I can finish off the limit question. Yours is going to be your homework, your responsibility to go and refresh your memory on the factorization. All right, so let's move on. So when I substitute this value here, and I look at it, I recognize, my x minus 3 can be canceled with the x minus 3 in the numerator. So now I can safely say that the x minus 3 was what was preventing the true limit of the function from coming out. So I'm going to remove it. I'm canceling it out. I'm canceling it out. And when I cancel it out, what I'm going to have is the limit as x tends to 3 of x minus 2. That's what is left for the question. That is in its simplest form. The same form that Sir started out the class with. The limit as x tends to something time of x plus 1. The one here is x minus 2. Same sort of something.
Was it? Oh, okay.
So what you're going to say to yourself now is, I'm evaluating it. Remember, at this stage, the only time we're going to be using the intuitive approach is unless they ask you specifically. If they don't ask you to use the intuitive approach, please do not use it. Whenever you're doing a question on piecewise, and the question comes in a particular way, matter of fact, your whole lot of piecewise, you will have to use the intuitive approach. That's piecewise. Otherwise, full-wise, no. So now, the limit as x tends to 3 of x minus 2. Anywhere in the function you see x, you are going to assume that x is equals to -2. And -2, no, sorry, 3. The limit is 3, sorry. And 3 minus 2 is going to be equals to 1. So the limit of that function tends to 1. The limit of that function tends to 1. So when we go to our indeterminate, it means they can't determine the true value of the function, pausing to say that there's something in the function preventing the true limit from coming out. You catch a piece there?
Yes, sir.
Yeah, man. Every time.
Sir,
So the limit of the
can you
function.
repeat that, sir?
And I'm just saying to you, there was something inside of the function that was preventing the true limit of the function from coming out. Now that we have isolated that x minus 3 and we cancel it out, we are then now going to be finding the limit of the simplified version. The simplified version would have been the limit as x tends to 3 of x minus 2. And we're using the calculations approach. So we're going to assume that x is equal to 3. So anywhere in the function I see x, I put 3. So x minus 2 is going to be 3 minus 2. And 3 minus 2 is equal to 1. So the limit of the function tends to 1.
Sir, explain the 3 part again.
Explain what?
The 3. The end of it. Where
anywhere in the function. Anywhere in the function. Go ahead.
I'm saying.
You
all right, so you were explaining, sir, where your substitute after you do the cancellation. Got you. So you put the I get it. So you put the 3 where you see when you after you done the cancellation now and you have x minus 2, you put the substitute the 3 where x is, and you come up with the 1. Okay.
Very good.
Oh, sir.
Yes, sir.
I was wondering where in the numerator in the algebraic expression how do you see in x minus 3 in the previous? So where in the numerator was x minus 3 when the numerator was in its previous form?
Inside of it, it was hiding in the x squared minus 5x plus 6. But in the expanded form, I will get x squared minus 5x plus 6. But in the factorized form, it's going to be x minus 2 times x minus 3.
Oh, so you have to put it in the factorized form to see it. Oh, okay, sir.
Yes, I. So that's how that's the limit it tends to. That's the limit it tends to.
1, sir.
Very good. Very good. All right. I have prepared some other questions to go through tonight, but I'm going to pause right here. I won't teach you anything new. I'm going to pause. Let me ask you, how was it? How was the first class?
Interesting.
Interesting. Okay. All right.
Sir, I'd say very productive.
Productive. Good. No, I want an honest feedback. Were you able to follow what I'm doing online? I want to know what to do in order to improve on what it is that I'm doing, so that when you leave the class, I feel like you get a good workout in class. That's what I'm asking you. How was it?
So you were thorough. You were thorough with the lesson. I have to go and read upon factorization so I can understand the last part, but up to the last part, I understand, I grasp it. When it just started off first, I wasn't getting it, but after we did the second exercise, and from there on, just to read up now on factorization.
Very nice, very nice. Anybody else? Don. talk to teacher.
Yes, sir. As long as you use the examples approach, sir, that you have used in this class, I can understand.
All right, very good.
All right,
Very
so
good.
you can scroll down, please.
Sure, no problem. Just $100.
I just want to compare the answers between the methods you use.
Oh, scroll down for which one?
Okay, so.
Okay.
Oh, all right.
All right.
Sir.
Yes,
They're
please.
going to send this document, sir?
Yeah.
All right.
Just $100. US.
I'm sorry?
Sir.
All right. Yes, please.
Sir, how soon you say you're gonna send the recording?
Somebody tell him for me, please.
They're on his YouTube.
Oh, okay.
Right. No,
All right.
he said how soon.
And sir is unable to say how soon based on the recordings are done by the school and the school send it to him.
Right. So if I am awake when the recording comes in, I just do it quickly from my cell phone. But sometimes there's a delay in the recordings coming in. So I may send it off tomorrow morning. As soon as the recording comes, I'll send it off to you. That's a commitment that I have for the class. All right. Students, one of the things I'm going to say to you, final thing I'll say to you is if you leave class, I know it's late now and you may want to just go and get, some food to eat and go sleep. But I'm going to say to you, don't wait until next Tuesday when we shall meet again that you're going to open your book. In that case, you're kind of going to be dark because you're going to forget everything. Your Editorsoft access is up. I saw we are a few people logged on already, and one person at a time spend a couple of minutes going through the tutorials. I'm going to ask that you start accessing your Editorsoft. For those of you who joined the class late and don't have your Editorsoft access or have not checked, I did say I was going to tell you. So all of you now have access. Well, all of you who sent me your email address in the group now have access to Editorsoft. If you are in class now and tonight is your first class, please drop your number in the chat so that you can be added either by number or link. And I'll add you to Editorsoft because you have work to be done and I'll communicate with you. But please, I beg of you, go through the stuff.
I didn't get anything.
Yeah, man.
You didn't email me, sir.
You had emailed me? Yeah, I sent the email in the stuff.
I sent, you said I should send, not since the ECC one wasn't up and running, I should send you my regular email and I send it to
guess what? No, but you should be able to find it because I use the ECC one. That's why you sent me 2 emails, but I use the ECC one. So you're not going to see it because it's not yet up. So do me a favor. When you go to editorsoft.com, put in your ECC email and you should access it. But you have access to it. You just have, because it's not yet up, you're not seeing the email coming to you. But you have access. Yeah, man, you have access.
Okay,
all right.
Sir. All right, thanks.
Good night. Thanks for being here with me. I'm going to do some relaxation now before I drop asleep. Thank you for coming out. Have a wonderful rest of the night.
All right, sir. Remember, post it.
Bye, sir.
Yeah, I will do. Take care. Yeah, I will do.
Same too, sir.
Okay.
Sir?
Yeah, man.
And to commute now.
All right. Yeah. All the best. Safe travels.
Sir.
Mm.
So I'm in Editorsoft now and I don't see anything.
I don't understand that you're not seeing anything. What do you mean you're not seeing anything?
Can I share my screen?
Sure.
Yes, sir. He started.
No, but you
the
won't see
course
anything
outline.
because, come on, you never gave me any email address.
Sure, I gave you one, sir. I was at the other class, sir.
You gave me at the other class. You put your email in the group, Mr. Erlington.
Yes, sir. Let me check.
No, sir.
But sir, I placed mine in the group as well, and I gain access, but I'm not seeing anything in it.
Yeah, man, it's supposed to be there, Leon.
I'll refresh it. Let me refresh the screen now. See.
Yeah, man, refresh it, man, because your assessments are there, your syllabus is there.
Oh, I see them, sir. You just yeah.
Okay, come on. Me know what me doing now.
Sir, I'll send it no again, sir.
No, don't use the word again. You never
Sir,
sent it before.
Sir, I'm not sure, sir, but I sent an email in my group chat, sir. I'm not sure if it's serious.
You never sent it. There are 17 students who sent it, and I double checked that the 17 emails that came in the group, I have 17 students on editor sort. So it wasn't sent. So go ahead and send it now, please.
Sir, I sent it in the WhatsApp group, sir.
Okay, now I'm seeing it. All right. All the best, guys. Later.
Bye, sir.
Come on.